Hello, uh, I'm Turjo and I'm supposed to talk about prototypical network yesterday, but I couldn't do it because we ran out of time. So here I am. So prototypical network is kind of like matching network in some way, but it is a much more simpler model. And so first I'll be talking about what it is, and then I'll try to compare it with matching network and see how it improves it. Um, so prototypical network is basically designed to do few-shot learning, and it is just like matching network. It is based on the philosophy that training and test condition must match. So if you want to do future learning, you want to train it to do better in future learning. So what it does is that it samples few levels or class levels from the training set, and then for each of these training classes it takes few samples of those. For example, it might take say 5 examples per classes, and then it builds a set of those examples, which is called the support set. So for example, say from our training set we sampled 3 class levels, and for each of the class levels we sample 5 examples only. Then our support set contains 15 examples, and each of them with 3 class levels. Each of the class levels has 5 examples. And then prototypical network learns a function f, which embeds those support set into a space. So here it is. This is the embedding of the support set. And ideally, we want this embedding such that each of the examples in a class tends to cluster together. So here we see that each of the 5 examples of the classes tends to cluster together. And then what it does is that it computes the mean of those points and tells that this mean is the prototype of this class. So this prototype is basically a class representative of the training examples. So when a new example comes and we want to find its level, what we do is that we embed this new example x using the same encoding function f theta, and find distance from each of the class prototypes to see in which class it belongs to. So these are the equations of the model. The first one here is used to find the mean of the embedded points of each class, which we call class prototype, and then we find the distance, and then when we try to find the level of a new example x, we embed it using the function f and find Euclidean distance from each of these class prototypes and do softmax over them. And as the last function we use log loss. So this is what I just said in an algorithmic form. So in the first line we are sampling few class levels from all the class levels, and then for each of these class levels we are sampling few examples for our support set. We are also sampling some examples for our query set. The support set will be used to find our class prototype, and for each of the points in the query set, we'll compute our loss. So in this paper, they talked a lot about why they used Euclidean distance instead of something like cosine similarity. So the main thing they said that it's in the family of Bregman divergence, and this family has some nice properties like the cluster representative that achieves the minimum distance from all the other points is basically the mean of this point. So what I mean by this is that if you have some points A, B, C and D and you want to find a point X such that the sum of all the distance from X to all the other points, which is A, B, C and D, is minimized. So basically we want to minimize these and we want to find such an X that minimizes this expression. So it can be proven that if D is in the family of Bregman divergence, then the answer is X equal the mean of A, B, C and D. And another point they mentioned is that if you use any distance in the family of Bregman divergence, then prototypical network is equivalent to doing mixture density estimation on the superset with an exponential family density. So the difference between prototypical network and matching networks are these: that prototypical network use Euclidean distance, where matching network use cosine similarity measure. And we have said that prototypical network is equivalent to doing linear classification when we use Euclidean distance, where matching network use basically nearest neighbor classifier. While prototypical network is very simple, matching network is very complex. Like they use BiSDM for attention mechanism also. And here they compare the result with other methods. They tested it in OmniClot and mini ImageNet dataset, both in 1-shot and 5-shot cases. In all of these cases, we see that prototypical network tends to win over matching networks. And we can also do 0-shot in prototypical network. To do that, a very simple modification is required, which is that we embed. So for 1-shot, we don't have training data for each classes, but we have some metadata. So what they did is that they embedded both the metadata and the query points into the same space, but using two different functions, G and F. So for metadata, they pass the data into G and embed it into this space, and to find X, the level of the X, they embed it using a different function F, and then they do all their stuff in that space, just like they did in the few-shot case. So that's all from me. If you have any questions about anything, you can ask me in the Slack, or you can send me an email. Thank you very much.